Catch him up.
We have a lovely dog in the neighborhood.
Okay, so number 1 is easy. Number 2, given a 90% confidence interval of 105 for mean heart rate, which of the following is the best interpretations for the confidence interval?
I
We are
think
90%.
First one.
Yeah, we are 90% confident.
Mhm.
Agree.
Me too.
Okay.
Okay, so researchers at a University of Mississippi wanted to determine whether the reaction time in seconds to go, no-go stimulus of males differed from that of females. The researchers randomly selected 20 females and 15 males to participate. The go, no-go stimulus required the students to respond to a particular stimulus and not to respond to other stimulus. Okay, the researchers decided to conduct a confidence interval to determine if the difference of the means is significant. To determine whether the difference interval would be reliable, they create a QQ plot of both random samples and see that they are approximately normal. Are the requirements of constructing a confidence interval satisfied? Why or why not? Wow, I love these books.
Let's not
This
read
one I was a little confused on, but I kind of felt like it might have been like B, yes, because it told you it was normal, but I don't know.
That's what I chose too.
Thought it was that as well.
Yeah.
Yes, that the distribution of the mean of each sample is normal since the data have been determined to be normal?
Yes.
Yeah.
That's what I
That's what I
chose.
figured.
Okay.
Okay.
Of the 4 types of confidence intervals listed below, which one is appropriate for this experiment?
Mhm.
Confidence interval for the mean of differences using dependent samples is what I picked. But I'm not good at this.
Yeah, that's the one I did using dependent samples as well.
So you guys chose confidence intervals for the mean of differences using dependent samples.
Yes.
Okay.
Do we have to
And
read
I
this?
thought that was because they had to use the mean, or like, you know, the number in between the two.
Right, okay.
So.
So for 5,
Mhm.
have obtained the balance of 90 bank customers rather than 30. Make a smaller margin of error.
And I put compute a 99% confidence interval rather than a 95%.
Okay. Tracy, do you have your slide?
My slide?
Your Excel?
Excel. Yes. Okay,
You can share
so
with us?
which one are we trying to get here? The top one?
Yeah, I think that's all
That's
out.
1,000.
There's her sippy cup on the couch.
Okay. Which one was it? I don't remember. Margin of error?
I don't know. It was one where you put in the 99% and the 95%, and that didn't shrink it. But when you put in the 90 instead of the 30, it did shrink it.
Okay.
Okay, so that was the
Oh, hold on. He's
95.
gonna show us.
The standard deviation was what?
Here, I can show you my screen. Are you sharing that?
No, not yet.
Okay.
I'm trying to figure out which one it was. So I think it was the margin of error. Or was it this top one? Just tell me which
Maybe I
one.
still have mine.
Computer's hot.
I don't think I did it.
It's okay.
I think it was the top one because you put in 30.
30 is what?
Because this is where we be where you put the sample.
Okay, so
You have
what's the standard
1.96.
deviation?
Deviation. I don't think we had.
Okay, so if we just put standard deviation of 10 and put the sample size ends of 30. Okay, Alyssa, I'm going to share my screen,
Okay.
and that way we can discuss this all looking at the same stuff here.
Sounds good.
Okay, can you guys see this?
Yes.
Okay, so this is the one I used here.
Mm-hmm.
So 1.96 would be the 95%.
Yes.
I just threw a standard deviation of 10 in there. I just don't think it matters.
Okay.
But I put the end value of 30.
Mm-hmm.
And so our answer came out to be 3.578. If we have 90 in there, that lowers our confidence, which it actually shrinks it, so it makes it closer together.
Yeah.
If we left this at 30 and put our confidence interval here at 99%, so it would be 2.576.
Yeah.
That actually rose.
Mm-hmm.
So that is why we chose having a larger sample size.
Okay.
That doesn't mean we're right. That's just that's the madness behind our reasoning.
Yes.
So why do you think it would be compute a 99% confidence interval? Why would it shrink it?
Because you think it would shrink it.
Sure.
I'm looking at my notes to make sure that I was actually thinking, I guess, right.
Okay.
Because what I was thinking was a smaller margin of error means like there's a less % chance of getting an error. And so I was thinking, oh, if you put 99%, there's
Right.
more area for it to be correct.
Right.
And so that's what I was thinking, and so I'm trying to make sure that I was thinking, I guess, correctly. So that's just what my brain was doing when I answered the question.
Well, it makes sense.
It makes sense.
So
We went to the spreadsheet to see what happened. Okay, and in that same spreadsheet, we did the next question, where we have the 1,000.
Are we ready to move on, or is she still looking at notes?
we can move on.
Okay. Okay, so number 6. Am I still sharing my screen?
Yeah, you are.
Okay, I think it's right there on the top, isn't it?
Yeah.
With I put the sample mean of 1,000 with our z-score of 1.96 because it wanted at 95%.
Yeah.
Standard deviation was 2, and our end sample was 4. So our confidence interval was 998.04 and 101.96.
Okay.
Can you see that on the screen?
Yeah, let me just look at it again on the screen. Okay.
Is that the top one for you guys?
Yeah.
Your answer? Okay.
And I think we put this one in the spreadsheet too, on the bottom.
0.001, yeah. Okay, so the z-score was 1.96, again, for 95%. Our standard deviation was 0.01. Our margin of error was 0.001. So we would have to have 38,416 samples.
Is that what you got to, Alyssa?
For number 6?
7, I think.
Oh, are we on number 6? Or, well, not technically. Number 7, I guess.
Oh,
Yeah.
Because I'm in the
I
quiz,
got
yeah.
38,416.
Right.
Yeah, that's what we got too.
That's what you said. Okay. Yep. That's what I got too.
Okay, very good.
Okay. For 8, it says the mean area of the several thousand apartments in a new development is advertised to be 1,250 square feet. A tenant group thinks that the apartments are smaller than advertised. They hire an engineer to measure a random sample of apartments to test their suspicion. The appropriate null and hypothesis tests are HO and HA for UR, and I believe I put the second one down is equals 1250 and does not equal 1250.
That's interesting.
Or, nope, sorry, that's not the one I put down. There's the first one.
Yeah.
Equals and then less than.
Less than? Okay.
That's what we did too.
Maybe I should actually look at my paper before I answer.
Nah, keep guessing.
I think it was a different problem I did that on, maybe. I don't know what I was thinking. But, yeah, so the first one there. That I put.
We struggled with a little bit.
Yeah, there were a couple in here that we really struggled with.
13 and 14 I really struggled with. So 9.
So number 9, in the statistical test of hypothesis, we say the data are statistically significant at a level of significance if, and I am not sure. I'm not sure what the question is actually asking us.
Yeah. I was kind of confused. I don't know.
We went with the second one.
Okay.
The p-value is less than the significance? Or the...
It's larger than.
Well, less than, because you would reject it if it was lower. So if you're saying it's statistically significant, then you would be accepting the hypothesis one.
At the level of significance. Okay. Yeah, I think that one's just...
I'm trying to think of what one it was as well. Because I think it's either less than, if it's larger or less, one of the two. I don't think it's the other one.
Right.
But
if the p-value is larger, then you wouldn't change the null hypothesis, right?
yeah, I think if it's... Well, that's the Nova one. So it says if the p-value is less than A, we reject the null. If the p-value is greater, then we fail to reject the null.
Right.
So I think it would be less.
Looking good, Stephen.
All right, so then we do agree. Hey, Stephen.
How are you?
Good.
Look at that haircut.
Nice haircut. Man, you clean up nice.
I'm so hot.
Every once in a while,
Yeah.
best I can.
Well, Stephen, we're on number 10.
Holy cow.
That's all right.
We can give you the answers.
Yeah, I'm still logging in. Give me a second.
All right.
Okay.
Guys, a session?
What was that?
Have you guys already came up?
Lost it.
Yeah, we lost him.
I can't hear ya.
You froze for a minute.
Can you hear me?
Yeah.
Yes.
Did you guys already come up to Payson to do a session?
Not yet. We went to the open house,
Okay.
which was stunning.
Alyssa, I know Idaho's a little ways away, but you gotta drive down to Payson.
It's
Okay.
true.
Well, we'll probably be down there. When are we going to Utah? 4th of July weekend?
Yeah.
4th of July weekend.
Cool. You gotta go.
We'll have to stop by then.
It's
So I'll
beautiful.
spend 4 days there. I've seen lots of pictures of it because all our family's gone, but
It's worth going.
yeah.
Sorry guys, the computer's slow. How many questions are on there?
26.
You want me to get her in the high chair?
If you guys want to keep going and don't for me, the internet is being slow.
Okay, we'll just come back to you then.
I'll do
Okay.
it.
Okay, so number 10. I will read the book, I
You
guess.
might want to wait for Alyssa.
Oh, okay.
She wants to put him in the high chair.
Oh, okay. Sorry. Do we need to read them?
I don't want to read them. Take too long.
They're books.
We have summer games opening ceremonies tonight.
What does that sound is?
What do you say?
Yeah, we can barely hear you. And it's just muffled.
Is that what that sound is?
Oh, no, we just got our door open.
Oh.
There's cars going by and
Dogs barking.
dogs barking. Yeah, somebody's getting arrested.
It's fun.
Yeah.
Can you hear me better?
Yes.
Yep.
I'm at my in-laws, so their internet is not the best. But that's probably
Okay.
better too.
Alright.
Okay, we will carry on. Number 10.
We chose yes. It is enough that the data are bell-shaped with no outliers.
And we've kind of decided not to read all of these questions, some of them being a book.
Okay, so number 10, this is the only one that I was kind of confused at because when it says, can they use the ANOVA hypothesis test to answer their question? I thought with the ANOVA test that it was always right-tailed. And I guess that's the only thing that confused me.
Okay.
But I mean, I guess it's kind of bell-shaped a little bit, but not really because it ends at the 0, right?
There was 2 things that needed to be done for the ANOVAs. Go back to lesson 14.
Yeah.
And then, what have I done? And it says, let me share the screen.
Okay.
Sure. And it says, we can conduct ANOVA testing when the following 2 requirements are met. The data are normally distributed in each group, and the largest variance is not more than 4 times the smaller. But
Okay.
so since it says normally distributed there,
Yeah.
that's why I went with it.
Okay.
Okay, so do we all agree on that one?
Yeah.
Okay. Number 11. We put down committed a type 1 error.
Number 11.
Yeah.
Okay.
Is that what you got also?
Yeah.
Okay.
12.
The type 1 error and the type 2 I always get mixed up, but I think that's probably.
And I think I had the.
That's one of those like I have a little question mark by.
Okay.
So
See if I can find where I got that. Was that 9?
It was right in on your last screen too. If you want to just roll up on that, the review.
So on 14, lesson 14.
So a type 1 error is committed when we reject the null hypothesis that is in reality true.
You say that's in lesson 14?
And a type 2 error is committed when we fail to reject the null hypothesis that is in reality not true. No, it was in, yeah. In your last screen you were showing.
wouldn't it be D? By reducing the probability of committing a type 1 error, we increase the probability of committing a type 2 error. Because I thought if one went down
No,
the other
that's
end.
on number 12.
Oh, number 12?
Yeah.
Oh, sorry. Are we still on number 11?
I thought we were discussing the differences.
Oh, sorry.
It's okay.
No, we're moving on.
Let's move on.
Sweet. Okay, helicopters. By reducing the... Yes. Okay, here's the tough ones for Leah and I.
Mm-hmm.
Yeah. Hey, this is going to get loud because all our games have started, I think.
Oh, close the door.
We're going to close the door. Hold on. Summer games started, so the helicopters are going to fly over the stadium. Which we're right next to.
You guys go to those? You guys go to the summer games?
Yeah. Check out some of the stuff. Okay. What do you have for 13, Melissa?
I don't have it.
You're in the same boat we are.
Yeah.
Yeah. That is about where I ended today when I was doing my work because my kids woke up.
Oh.
So.
Okay, I think I had this one on there.
Is this the one, though, where we would have to find...
Like you find the T-score or
Yeah,
something?
you find it, and then, like, you subtract that part, you know, and so you kind of have that small area that it could be in? Or...
Okay,
well,
like the probability applet?
no, I don't think it was in the probability. Well, I'm trying
Okay.
to look at the answers and see what they actually want.
We had this in your Excel sheet.
But yeah, I think you do need to use
I'm going to screenshot
what you were using in the Excel.
it. Okay.
Let me just find what chapter it was in.
You have it plugged in.
Oh. That?
Your
Yeah.
data plugged in.
Yeah, it's right there on the bottom.
Okay.
Did you guys already go through and do all these questions?
Can you see my... Yeah.
Yeah.
They did. I haven't.
I want to watch
What?
fireworks. Do you want me to go back, Steven?
So I
Sharing my
got...
screen here.
Oh,
Can you see
okay.
these?
Hey, who's got through this time?
What did you say?
No.
Do you need me to scroll down, Steven?
Give me 1 second.
Okay.
What time does your fireworks start?
Dark. We got a little while.
So we better hustle.
Are you logged in?
Okay,
Me?
so
Well, are you logged in, Stephen, to get caught up?
So I'm on question 5 now.
Okay, let me arrow down.
Yeah, Tracy, I do think this is something that we might use the applet for. And then I
okay.
think we find the area, and then the area is our p-value. And so if the p-value is larger, we fail to reject the null, and if it's smaller, we reject.
Can you go back up, Leah?
Yeah, sorry.
Okay, so then we would use, so in the normal probability applet, we would do on what, to the right side and put 5% in?
Well, I think we might have to use the formula with the z-score over.
To find the t-score?
No, I think we have to find a z-score for this one.
Well, I don't have a formula for the z-score, unless this is the same. Can you see my screen right there?
I could be all over the place, but
How you doing, Stephen?
Good. So
Go down.
15. You can scroll down to 15 if you're okay with
Well,
that.
we're on 13, Stephen.
Oh, 13?
Yeah.
Yeah,
Sorry.
that's
What
where
do
we're stuck.
What do you have for 13?
Me?
Yeah,
I would say reject the hoe.
that's what I say too.
That's just a good rule to always go by.
I agree.
Okay, so what did you put on that?
I put reject.
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 The hoe.
Okay.
So, do we agree with that? I mean,
Sure.
You got 1.7.
yeah, if I
But
throw
we're
in,
confused.
if I use the formula on that screenshot you guys see, I end up with
Yeah.
that score of 1.765.
Mhm.
Or if I throw in the normal probability applet and put 5%, and why I did that is at 5% level of significance on the bottom part of that question. That's why I put 5% in, and clicked onto the right-hand side. It gave the z-score of 1.645. So I don't know. I'm just kind of
It's still over 1.5.
either way, it would say to reject the hoe.
Yeah.
Yeah.
Okay, so we'll move on then.
Okay.
All right, so number 14, you would like to look at the mean number of hours worked for wages per week by male students and female students. You would like a random sample of 100 for each group and test if those means are different. What is the correct statistical procedure? I would like to say, good question.
I picked independent.
Okay.
Because I don't know. Because I did.
Well, I don't think it's a no because they only have two means
Right.
that they're kind of looking at. It's not paired.
Yeah, it doesn't matter what boy or what girl. They're just two
So
groups.
it takes those two out.
So
And then we go eeny, meeny, miny, mo,
You
and come up with independent.
I like independence
like independent?
and fireworks.
Stop it. All right, so we're good on that one then,
Okay.
we think. Okay, so number 15, an educator is interested in academic achievement. I'm not supposed to read these, I guess, from Okay. What do you want me to do? Dependent sampling. If you select a brother so as to compare the academic achievement to his sister, you might include the sister in your study.
Yeah, I think it would be independent.
Independent?
I
think
think.
it's the last one.
You think it's dependent?
Yeah, I think it's the bottom one because it says she decides to use only brother-sister pairs when they're next to each other in sibling order.
Okay.
So it's
I guess
relying on that
we're trying to
brother-sister.
decide
yeah, if you read
if
it,
the numbers are actually depending on each other or not.
Yeah, because if she uses a brother, then that brother's sister is in group 2.
I would say it's B.
You mean it's D2?
Well, just by reading what it's saying, that's what makes sense to me. If we're supposed to read the question.
Yeah.
Yes, you're supposed to.
Liam might not
To guess blindly, actually. I'll go with whatever you guys say this one.
Oh, pressure's on.
I know. I'm just trying to. I just don't feel like it's saying what even they're trying to get. Like if whatever his score is actually dependent on his sisters or not. And I guess.
Comparing the two, right?
But then I can kind of see where you guys are getting the dependent too. So. Anyway.
And that part I highlighted is the only reason I think it is the dependent.
Yeah.
Is 16B? No.
I was just starting to read it. So.
You want to share your report?
Yes, let's go on to
Oh
that.
yeah, we have to open up the data
Yeah,
file.
if I can.
We've run this. It gives us a standard deviation in the report.
Okay.
That's kind of why I selected A.
Okay.
Tracy, I think, sharing.
Trying to.
That's good.
Trying to share.
Okay, did I pull up the right one? What are you looking for?
I think so. We're looking for. Oops, I just mixed it. So we're trying to figure out, of the 4 types of confidence intervals listed below, which one is appropriate for this situation. Now, it shows a standard deviation in your report.
Yes. Let me get to it. 4.325, 326 actually.
but it has a standard deviation. So we know that part.
And so the confidence interval for you when standard deviation is known, or the mean when standard deviation is known.
I mean, at least that one's in there.
Right.
So I think we can rule out B.
Mm-hmm.
I don't think we're looking for the differences.
No, I don't think so.
So then it'd be independent. Right?
I think it's the top one.
I think it's the top one too, because
Okay.
the middle one's about unknown, and then the other two are really talking about differences.
Differences, yeah.
So I think it's the top one as well.
Okay. And so number 17 is the 11.168.
Okay.
So it's the bottom one, and
Okay, I see where you-
15.217.
You see where that's at?
Yeah.
Does my arrow go right over that?
Yeah.
Yeah, pretty close. Well, not
Close
right on
enough.
it though.
That's
Yeah,
about
close enough. Okay.
Is it 18D?
That's what I have selected, but I don't know if it's right.
But, wait, one
Oh,
sec.
the Hummers. Are you sharing that one?
The Hummers. Yeah, I'll need to get down. I need to find it here. Carbon levels. I don't know
So
how
18,
far.
you're thinking D, random sample, beta.
Alright, you're right.
Okay, so we're on the. This is the Hummers, right?
Mm-hmm.
Okay. You guys see that?
Is 19C? Yes. I did not look at your screen and I guessed on both of those.
Wow.
That, you're a good guesser.
Let's hope we're all a good guesser.
What did you guys put for 18?
I put D.
D, okay. That's what I thought.
And then for 19, negative 423 and
Yeah.
5417.
And that should show up on his screen.
That should be right on the
That right
screen.
there on your screen.
Okay, perfect. Okay, next one. Which one do I need? What is this one? The bone density?
Yes. Density.
Yeah. Density. Okay. So number 20, we have ANOVA.
Yeah.
Yeah, I think so, because it's 3 different groups, or,
Right.
yeah. So I think it's ANOVA.
There's probably more French words in there than so.
Then we need to calculate the test statistic.
Yeah, that should show
It
on
should be
Tracy's.
on the thing right there.
Okay.
The 7.978,
All right.
if I did it right.
It looks-
So, hey,
How my screen looked normally.
Sweet.
I don't have it on right now.
And the p-value's 0.002. Okay.
And so the p-value's lower, right, on this one.
Yes.
So that
I
would
have number 2 selected. Because at least one of the groups is
okay.
Okay, so next one is
I agree as well on that one.
okay, good.
okay.
Makes me feel a little more confident.
23 is B.
Yes.
What do you guys put?
Yeah, B.
Can you see it still, Stephen?
No, I moved it up.
No, I was talking about my
Oh.
screen.
Sorry.
Yes, I can.
Okay, so the next one, we put dependent samples test.
So, like, not a lot of it's going to be out.
I'd agree with that
Okay.
because they're comparing them.
Is the p-value for this one C or D?
Do you have the direct points up there?
Yes.
So test statistic 1.685.
Yep. And the p-value is 0.096.
Earn it?
Okay.
So with the p-value being under the 0.10, there is sufficient evidence to conclude that there is a difference in the cost of ticket purchase 14 days in advance compared to 90 days in advance.
Yes. Agree.
Okay, so hopefully, I mean, this one kind of threw me off because I kept trying to figure out, okay, well, what's the p-value is low, but what's the hypothesis?
Yeah. Looks
So,
like they got number 4 wrong and 5.
They were all thinking about
So 4 is a confidence interval for the difference of means using independent samples.
Really?
Mm-hmm.
Really?
Oh wait, no, we got 5 right. Obtain the balances in 90 bank customers rather than 30. So you guys are good there.
So 4 was independent?
Yes.
just keep remembering that, you know,
So yeah, 4 was.
their
4 was the only
the
one?
last one. Then let me scroll. So far all these. Oh, and then 16 was the second one down. So confidence interval is for the U when the O is unknown.
But it tells us one. That makes no sense.
Yeah, it confuses me even more.
Right?
I'm
Awesome.
sorry.
Did you say
That's
16?
okay. I agreed with you because
Yeah.
both all of us, and those were the only 2 we got wrong.
Sweet.
It looks like. So.
No. Is that right? 16B?
And I didn't put in. It's good I looked at my thing before I repeated it.
Now I'm afraid I might have moved something.
Hey, 21 is wrong.
You got 21 wrong?
Yeah, what did you guys put?
7.978?
I must have bumped it to a different one.
Okay.
Yeah, it's 7.978. Darn it. All right.
Sounds good.
You guys are awesome.